Good morning. Good morning, everyone. So it's already 9 o'clock. So uh, we should start now. And we're told that we're supposed to end by 10:25 a.m. because this virtual room will be used by another session. So a gentle reminder to our presenters, please present for 15 to 20 minutes to give enough time for the open forum. Okay, so welcome to day two of our annual conference. And for this session, our topic is economic growth, and we have three exciting presentations today. First is on the evolution of the Philippine economic landscape, and second is a study using macroeconomic determinants affecting happiness, and a study on probabilistic networks of economic activities. So let's begin with the presentation on the Philippine economic landscape. The exact title is Evolution of the Philippine Economic Landscape 2000 to 2018. This is co-authored by Rolly Tsar, Joseph Castillo of the Labor Education and Research Network, and James Matthew Miraflor of the Department of Computer Science, University of the Philippines, Diliman. So please proceed with your presentation, and then we'll have...
Close na lang, ma'am.
Yes? Okay. So kindly kindly mute yourself, yung mga participants who are not yet supposed to speak. And then, so after the presentation, let's devote around 5 to 10 minutes for the open forum for the question and answer. So please proceed. Thank you.
Hello, good morning. Can you hear me and can you see my slides?
On my end, that's okay.
Right.
The slides are okay.
Again, good morning, everyone. And we thank the PES for giving us an opportunity to share our work. This is a joint work by James Miraflor, who is also a presenter in this panel. And well, this is a work in progress, and what I will be presenting are our preliminary results. Okay. So how do we characterize structural transformation? Okay. The standard practice involves examining the shares of industrial sectors and subsectors to the gross value added and determining the distribution of resources allocated to each economic activity. We usually say that when there is change in the distribution, it is possible that there is also change in either technologies or preferences or incomes. Over time, we observe that as incomes increase, economic agents reallocate their factor endowments. Now, in most countries, the direction is away from agriculture towards higher value-added activities such as manufacturing or some service activities. Now, all of these occur through the interaction of agents in the market, primarily through supply and demand. Let's look at some examples based on data. So in this plot, so we show the distribution of value added by sector over the period 2000 to 2020. This is based on the national income accounts. And as you can see, retail trade has been a dominant sector. Retail trade is this gray area here. It has been a dominant sector in terms of its share to value added. Another relatively big sector is manufacture of food and beverages, which is given by this area, light blue area. Okay. So let us look at another example. So here we can characterize the economy this time in terms of the composition of consumption. Okay. So in this plot, we show the composition of household expenditures. And as we all know, food and non-alcoholic beverage consumption accounts for the biggest share in expenditure of households. It's more than 30% all throughout the period. Okay. And here's another example. So another practice is to look at the distribution of investments, so the flow of capital to sectors. In this plot, we show capital formation according to its components. So over the same period, year 2000 to 2020, and the biggest should I say, investment expenditure items are, well, there are a lot. No? So this one, this orange area here, over time, we see that its share to the total inflow of investment has been increasing, relative to the others. So this is construction by private corporations. Again, this plot is based on data from the national income accounts. Okay. Now, let me just mention that apart from simply characterizing structural transformation, another interesting subject of inquiry is the cost of structural transformation. And this has been explored in literature. So there are supply side arguments. So for instance, supply side arguments, they tend to focus more on the technological changes. No? So on literature, so by Baumol in 1967, non-balanced growth resulting from differential productivity growth across sectors. So that's one cause. There's also the low elasticity of substitution across final goods, and this leads to shift in employment shares to sectors with low TFP growth. And finally, Asimoglu points out that capital deepening benefits or leads to non-balanced growth in favor of more capital-intensive sectors. So that's the supply side arguments. Meanwhile, there are also demand side arguments. And for instance, Kamin et al. In 2020, they argued that there will be reallocation of demand due to non-homothetic preferences when incomes increase. Okay, so there are sectors that will benefit from rising incomes over time. Okay. Now, there's another way to view structural transformation, and at this time by looking at interdependencies of sectors. And this approach mainly uses the intersectoral flows according to the input-output table. Okay. The forward and backward linkages computed from the IO table are among the most popular indicators of the importance of a sector to an economy. So for instance, we can identify sectors that can be considered a key sectors. No? These are the sectors with strong forward and backward linkages. So this is so one practice is to identify these sectors and prioritize them in economic planning. Okay. Structural transformation is then tracked by comparing IO tables and linkages over time. Now, we can actually observe two forces that operate on linkages over time. Okay, so on one hand, you have modernization that entails an increase in intersectoral linkages as more sophisticated goods and services require more inputs from other sectors. So meanwhile, there's also an argument that as sectors specialize, each industry obtained its input from very few supplies. So in a way, creating small clusters of networks in the economy. Okay. Now, both of these effects can be observed over time. Okay. Right. So in 1995, Sony's proposed an approach in viewing economic landscape. Okay. They call the approach multiplier product matrix, or MPM, which is just the product of forward and backward linkage strength of each sector divided by what's called the global intensity, or the sum of the entries in a Leontief multiplier matrix. Well, now, one thing nice about MPM is that it can produce nice visualization of the economic landscape at a particular period. And one can generate MPM for several periods and then compare them. Okay. Now, what's the multiplier product matrix? So suppose we are given an input-output table, and let A be a square matrix of the technical coefficients of input-output table. So Aij, so entries, with n sectors. Okay. And suppose B is the Leontief inverse, which is given by the inverse of I minus A. Okay. Now we define the backward and forward linkages as, so the backward linkage is just the sum across rows. Okay, so for each column, no. So take the column sum. Okay, where meanwhile the forward linkage is given by the sum of the entries across rows in the Leontief inverse. Okay, the MPM is defined as the matrix that results from this is scalar multiplication. No, so we multiply this. This is a column vector, okay, multiplied by a row vector. So you get there an n by n matrix. Multiply that by 1 over v, which is just like normalizing the entries in the MPM. Okay. Now the rows and columns of the base MPM are then sorted according to the backward and forward linkage strength. So once we obtain the MPM using this formula, we sort the rows and the columns according to how strong backward and forward linkage of a sector is. Okay, so this is the initial sorting, and this produces a starting economic landscape. Now we fix the ordering of the sectors, okay, and we compare MPMs across time. Okay, Magtibay Ramos and et al. In 2011 did an exercise for 11 major economic sectors in the Philippines using IO tables from 1979 to 2000. Now in this paper, we will try to replicate the method, this time using the input-output tables from year 2000 to 2018, but we'll look at more sectors. So first we'll look at 16 sector input-output table. Then we will extend the analysis to 62 sectors. Okay. One thing that we will introduce in this paper is we'll try to come up with IO tables for each of the quarters, intervening quarters over the period 2000 to 2018. Okay. So what this does is that it allows the calculation of a more fine-grained landscape from which better temporal analysis can be performed. Okay. All right, so this is what we will do to visualize the Philippine economic landscape for 2000 to 2018. We first construct quarterly input-output tables for the periods in the interval 2000 to 2018. We only have like 4 input-output tables, okay? So to do this, to generate quarterly input-output tables, we implement entry-wise interpolation of input-output tables to generate missing values in the time interval. So let A be the, so this time, this is no longer the technical coefficient. So earlier I used this notation to denote technical coefficient. This time, this is the input-output transaction table, okay? Where T here is an element of the set. T is equal to 2000, 2006, 2012, 2018. These are the years where we have available input-output table. Then, using these IO tables, we construct sequences of points consisting of entries from the available input-output tables, okay, with the same addresses. So here's an example. So pick an address IJ, and so the first entry here is from the year 2000 IO. The second entry is from 2006, 2012, and then 2018. Now we do this for all the entries in the IO. So that's 62 by 62. Okay. So once we have that, now the entries here in this sequence should be described by a function. Okay. So it's like a trend over time. So here's our interpolation problem. Suppose there's a continuous function f in the interval 2000 to 2018, such that at time t, f of t equals the respective entry in the input-output table. Okay, so this is from our data. Now we want to find an interpolating polynomial p such that at time t, so the value of p at time t is equal to the value of f at time t, which is just the our entry from our available input-output tables. So meaning it should be able to reproduce what we know. So here's the illustration. So suppose, so these are the available data points, no? And for these entries AIJ, so this is for year 2000, 2006, 2012, 2018, a function exists that describe this trend, okay? We want to find this function, or rather we want to find an interpolating function such that we'll be able to generate these points, okay? Now using that function, so that's P, no? So we use the interpolating polynomial P to generate the IO entries for T in this time interval that are not equal to 2000, 2006, 2012, and 2018. So meaning all the periods in the interval 2000 to 2018. Okay. Now, again, the AIJ with superscript T prime are the entries of the intermediate input submatrix of the input-output table for the period T prime. Okay. Now, to generate the AIJs or to find the interpolating polynomial, we use the piecewise cubic Hermite interpolating polynomial. Actually, we can use any interpolating method. In fact, originally, we just used the linear piecewise interpolation. No? But this time, we're using the p-chip because the p-chip preserves, apart from preserving the shape of the data, it's also continuous and twice differentiable. Okay. We numerically implement our method in MATLAB. Okay. Now, so after doing that, after doing the interpolation, we come up with several input-output tables. Now, we still need to compute the Leontief inverse. Now, computing the inverse requires sectoral output, no? And to compute sectoral output, we need sectoral value added. Now, so here we use sectoral value added from the national income accounts. And so once we get the output, we can now compute the Leontief inverse. Okay. And then we proceed to computing the MTM. Because remember, if you have the input-output table, right? So you have the intermediate inputs here, and then you have the value-added block, and the output is just the total. Okay. But we only interpolated this part. So this one, we got this from the national income accounts, so in sectoral. Okay. So when we already have this one, we can compute technical coefficients for the quarterly input-output tables. Okay. Now we express all values in terms of 2018 prices. So 2018 is our base year. Now let me show you our result. So we first implemented this for 15 sectors, or rather 16 sectors. So here is the initial MTM, so multiplier product matrix. And over time, let's look at how the economy evolves. I hope you can see the figure playing. Okay. So some sectors emerge here. So over time, like for instance, manufacturing. So this one is manufacturing, but this is manufacturing in general, no, or rather the aggregated manufacturing activities. This one, AFSS, is what's the second? Food service and accommodation. Okay, so this is food service and accommodation. TAS is transportation and storage. MFG is manufacturing. As you can see here, it has become an important sector in the economy. But this is only because we're looking at a 16 sector MPM. Okay, if we look at more sectors, so higher dimension, at this time, this is not sorted. the sorting here is based on how they appear in PISIC, so Philippine Industrial Classification. I identified here sectors that emerge as important over time. No? So from year 2000 to 2018. Let's run this. And as you can see, the MPM, okay? So wholesale and retail trade appears here as a dominant sector. Other dominant sectors are petroleum products, other mining activities were relatively small. And of course, we have the banks and real estate activities. So these are the most dominant sectors over time. But one thing really nice here is yung retail, wholesale and retail trade really emerge as an important sector. Now, you may think that this is inconsistent with the earlier result. So yung lower dimension, no? When we only consider 16 sector, that's because the aggregation of sector really impacts the result of MPM. Okay. Earlier, what I showed you earlier, manufacturing activities is composed of a number of activities. So it's not just one sector. Whereas, trade here is this. Actually, that's already the aggregation. No, trade is only just one sector. Okay, so it may appear less important in this case. Okay, but if we look at the finer, if we look at the MPM in higher dimension, we'll see that wholesale and retail trade has gained importance in the economy over time. No, okay. Another way to look at the MPM actually. So this is just the 3D plot. We prepared another visualization. This time, we'll look at the networks formed from MPM. So let me show you another slide. I hope you can see this. These are the networks generated by the MPM, but we only visualize the most important networks, meaning when the MPM exceeds some threshold. So as you can see here, the circles here are the sectors, and the lines are the forward and backward linkages. The thickness of the line is based on the MPM value. So in the matrix, so the red, or maybe the orange circles are your industrial activities. The blue circles are the service activities. The yellow one is food products. This one is tobacco. The green ones, I don't know if you can see the green ones. Those are the agricultural activities. The size of the circle is a function of the total intermediate inputs that a sector uses. Okay, so a larger sector tends to have higher intermediate inputs. So here, the most important sectors are, so first you have, there are many sectors under this aggregation. Okay. So this one is non-bank activities. This one is food products. This one is other mining activities. Again, there are many subsectors here. This one is chemical and chemical products. Okay. Now let's look at the network generated for year 2006. This time we have dominant sectors. Okay. This one is wholesale and retail trade. So it already emerged in 2006. This one is computer, electronic, and optical products, one of our, should I say, important industrial sector. This one is food products. Okay, this is in 2006. Now let's look at how this changed in 2012. In 2012, wholesale and retail trade gained more importance. Perhaps you can think of the emergence of big shopping malls, no? Okay, but one thing to notice here is that this sector, computer, electronic, and optical products, disappeared here. Okay, perhaps maybe due to the global financial crisis, its exposure to the global markets. Okay, and then finally in 2018, so this is now the net worth generated for 2018. This is still wholesale and retail trade. Looks like a permanent fixture in our economy. This one's food products, also a permanent fixture, but this time it's of relatively less important compared to trade or retail trade. Okay, so let me go back now to the slide. So let me end with some observations. The industrialization in this case is more observed when our sectors are more disaggregated, no? Okay, and this one is something that we will explore more in the future. Because earlier, when we look at 16 sector, so we saw the importance of manufacturing, but then one may think that the complexity of a sector really matters a lot, because when a sector has a higher value added, so mas maraming activities yun nandun, its importance in the economy becomes, should I say, larger or bigger, no? Okay, and this is also something we observe over time, the increasing dominance of wholesale and retail trade. Okay, so another future work. So in the future, we'll look at growth based on the input-output approach above. So we'll decompose growth based on you have the value added, changes in the value added, and how the sectors use intermediate inputs. So that's one thing that we'll look at in the future. All right, so that's all. Thank you
Okay,
for
thank you.
listening.
Thank you, CJ. Actually, you exceeded the time allotment.
Oh,
so
sorry.
reminder to the other participants, please stick to the 15 to 20-minute presentation. And by the way, correction on my announcement earlier. So as advised in the original email, the presentations will, all of the presentations will proceed first, and then after all the three presentations will exhaust the remaining time for the Q&A. Okay, so thank you, Mr. Castillo. And then next, let's listen to the presentation entitled Macroeconomic Determinants Affecting Happiness, a panel data analysis in Asia Pacific region, to be presented by Kizia Joy Kayunda, Haisil Gapor, Tricia Nicole Lusing, and Renzo Sumagang of the Mindanao State University Iligan Institute of Technology. By the way, I used to be a member of the Board of Regents of the MSU when I was still a USEC of NEDA. So welcome to this session, and please proceed with the presentation.
Good day, everyone. We are the researchers from Mindanao State University Iligan Institute of Technology, and allow us to present our research entitled Macroeconomic Determinants Affecting Happiness, a panel data analysis in Asia Pacific region. Now, happiness economics has been one of the most rapidly growing disciplines of economics in recent years. That's according to SIGROI 2010. Here is our presentation outline. Now, our for rationale in 2019 World Happiness Report shows data that negative feelings are rising across the globe, thus people are not happy. In a country ladder assessment used by the World Happiness Report, countries garnering 7+ points are considered as thriving countries, while those countries garnering 4 up to 7 points were categorized as struggling countries, and countries that garnered below 4 points are considered as suffering. That's according to Gallup 2009. Now, in addition, in 2021 World Happiness Report shows average happiness index in Asia based on 39 countries was at only 5.35 points. This average point earned in Asia is classified as struggling with moderate and inconsistent well-being and is predicted to suffer in the future. The 2018 World Happiness Report also revealed that happiness inequality in Southeast Asia region has been rising since 2010, and in the rest of Asian countries rising much less. And also, while many studies on life satisfactions have been conducted in Western countries, there is still a dearth of such studies in Asia and other parts of the less developed world. That's according to Ngo et al. 2015. Now, most of the previous literature looked into macroeconomic impacts of happiness on the economy and often forget to explore the other side of the coin. They have not sufficiently scrutinized the potential macroeconomic factors that could affect the rise and the fall of the happiness index in a certain country. Now, this study will be examining the macroeconomic factors that affect happiness in 41 countries in Asia Pacific region in a time period of 2012 to 2019. In this graph shows the average happiness index of 6 regions in Asia Pacific, namely Central, East, Pacific, South, Southeast, and Western. And it's very evident that the Pacific region is very far from the other regions in the Asia Pacific region. Now, this paper aims to analyze the macroeconomic determinants that have the strongest influence on happiness and specifically seeks to attain the following objectives. First is to describe the status of happiness in Asia Pacific region from 2012 to 2019 in terms of happiness index. Second is to examine the relationship between happiness in Asia Pacific region from 2012 to 2019 and the macroeconomic factors. Lastly, to identify the significance of macroeconomic factors that affect happiness in the Asia Pacific region covering from the period of 2012 to 2019. Here are our variables. First is our happiness index. Second is corruption perception index, inflation rate, unemployment rate, global freedom score, the income classification, and regional classification. Let us review first the related literature. In the happiness index, the happiness measure, even though self-reported and subjective, is reliable. Precision varies and valid. That's according to Dettalia and Makulov 2006 and Myers 2000. The Gallup World's Happiness Index is determined based on responses to questions composed of 9 components that determine happiness. First is psychological well-being, health, education, time use, cultural variety and resilience, good governance, community vitality, ecological diversity and resilience, and living standards have all been used to explain the notion of happiness reports that's according to the United Nations. For the Corruption Perception Index, according to Transparency International, the results are given on a scale of 0 as highly corrupt to 100 as very clean. A study of Lang 2012 and Wu and Zhu 2015, corruption has an inverse relationship with happiness because corruption experience means poor quality of governance, thus lowering people's life satisfaction. The rate of inflation has an adverse relationship with the happiness index in life. As the rate of inflation rises, people are discouraged from purchasing more commodities as the overall price level rises. In most research, inflation was found to have a negative impact on happiness. People who had never been unemployed reported higher levels of life satisfaction than those who had been previously unemployed. That's according to Richer et al. 2020. Moreover, the negative effects of unemployment on life satisfaction increased during the period of being unemployed and remain even after individuals re-enter employment. The Global Freedom Score and Happiness Index have a positive relationship. According to the Winter 2018, economic freedom as well as political freedom is the most consistent in establishing a positive relationship to happiness. Brooks 2008 revealed in his study that freedom and happiness are highly correlated and even more significant. It has also shown that freedom even causes people's happiness. The income classification, a research study by Dieton 2008 and Sachs 2012, found that per capita national income has a considerable impact on life satisfaction and is considerably strong in rich countries. The same result of the study of TAN 2021 yielded a significantly positive relationship between happiness and income classification, but on a lesser magnitude of impact.
Good morning once again. This study incorporates a range of theories related to the economic aspects influencing each individual's happiness and well-being. Let us start with the Easterlin paradox theory, which is a finding in happiness economics by Richard Easterlin, the first economist to study happiness data. This theory relates the impact of income on a person's happiness level. It claims that at a point in time, happiness varies directly with income both among and within nations. But over time, happiness does not increase as income rises. The idea look at how people compare their incomes to that of others or to their previous selves. The concept is that the happiness you gain from an increase in income can be countered if others get bigger compensation or if you get a smaller raise than you expected, resulting in the national happiness level remaining the same despite ongoing income growth. In other words, this theory proposes that income and happiness are positively related in the short run, but not in the long run. Second theory that we have included is the Richard Layard's theory of happiness, which revolves around social factors shaping happiness through the integration of neuroscience, sociology, philosophy, and economics. Layard's theory of happiness focuses on the common good rather than the rampant individualism, enhanced by progressive economic growth. Layard developed the Big Seven, referring to the 7 factors as what makes people happy or what affects a person's well-being, namely family relationships, financial situation, work, community and friends, health, personal freedom, and personal values. In this study, we aim to examine the effects of the 4 out of the 7 factors, such as the financial situation using the income classification, work using the unemployment rate, community and friends using the corruption perception index and the regional classification. And lastly, the global freedom score for the personal freedom factor. Next is the William Thompson's radical democracy, which claims that happiness is as much a matter of the structure of society and social institutions as an individual pursuit. The cornerstone of democracy is freedom. Now, William Thompson's radical democracy theory can be associated with this study, as this study also aims to examine the relationship between the individual happiness or well-being and a country's freedom. In Thompson's case, democracy. This theory claims that the more freedom the community has or the individual enjoys, the happier they will be. Another theory that we have incorporated in our study is Kate Raworth's donut economics. This is an economic model that balances essential human needs and the planetary boundaries. The starting point of this theory is to change the goal from endless GDP growth as the basis of economic growth to thriving in the donut. The donut consists of 2 concentric rings, a social foundation to ensure that no one is left falling short in life's essentials. In this study, variables such as global freedom score, corruption perception index, income classification, inflation rate, regional classification, and unemployment rate may fall in the inner concentric ring of the donut. The outer concentric ring is the ecological ceiling, to ensure that humanity does not collectively overshoot the planetary boundaries that protect Earth's life-supporting systems. In this study, the carbon emission metric tons per capita may fall in the outer concentric ring of the donut. This study conforms to the donut economics theory that GDP should not be the sole determinant of economic growth and that policymakers should look at other factors in aiming sustainable development. Mainly, this study will undertake an econometric analytical approach using a panel data regression analysis, commonly known as longitudinal or cross-sectional time series data, through the use of Stata statistical software. The study will undergo several diagnostic tests, and some of which are the following. Initially, a Hausman specification test was used to determine which model is suitable for assessing panel data between fixed and random effects. As per the null hypothesis, the preferred model is random effects, while the alternative hypothesis preferred model is fixed effects. The Hausman test results show that random effects is the best model to be used since the R-squared is greater in the random effects model compared to the fixed effects. This study also conducted the Pesserant's cross-sectional dependence test to examine if there is cross-sectional dependence between the units, in which the results show that there is no cross-sectional dependence among variables. Next, we perform the serial correlation test to determine whether the variables used are highly correlated with each other. Based on the result of the correlation test, 3 independent variables showed a strong correlation to the other variables, namely the GDP per capita, CO2 emission metric tons per capita, and the public health expenditure per capita. Thus, we decided to omit those highly correlated variables. We also ran the variance inflation factor test and found that the model has no serious multicollinearity issues. Moreover, the data were examined for panel-level heteroscedasticity and revealed that there is a presence of heteroscedasticity. So to resolve the issue of correlation and heteroscedasticity, panel-corrected standard error, or the PCSE, was used. Now, here is our empirical model. The specification of the empirical model for this study, as stated in equation 4.1, is based on the earlier empirical studies of the following researchers. The model is specified as follows, where HI denotes the happiness index of Asia-Pacific countries, and since we use panel data, I denotes countries, T denotes time period, beta sub 0 is a constant variable, beta sub n is the slope coefficient associated on each independent variable, and where CPI denotes corruption perception index, INF denotes inflation rate, UNEMP denotes unemployment rate, GFS denotes global freedom score, INC denotes income classification. And since income classification is a categorical variable, we use high income as the reference variable. We assign 0 for high income, 1 for low income, 2 for low middle income, and 3 for upper middle income. Same goes with the REGSI, which denotes regional classification. This is also a categorical variable. We use Western Asia as the reference variable. We assign 0 for Western, 1 for Central, 2 for East, 3 for Pacific, and 4 for South, and 5 for Southeast Asia region, plus the error term or the residual term. This study employs an annual secondary panel data for a sample of 41 countries in the Asia-Pacific region, covering over a period of 8 years from 2012 to 2019, with a total of 328 observations. Some countries were excluded from the study due to the unavailability data on the dependent variable. For the dependent variable, which is the happiness index, we obtained the data from the World Happiness Report from years 2012 to 2019 in the countries of Asia Pacific region. The data for the World Happiness Report comes from Gallup World Pulse surveys, which are based on responses to the Pulse primary life satisfaction question. For the independent variables, the sources of data on income classification, inflation rate, and the unemployment rate were obtained from the World Bank, particularly the database of World Development Indicators, and the regional classification from the United Nations, and the Corruption Perception Index and Global Freedom Score provided by the Transparency International and Freedom House, respectively.
Good day once again. We are now on the results and discussion. The graphs or figures displayed on the screen illustrate the status of happiness of each region in Asia Pacific. First, the figure 6.1 is the status of happiness in the Central Asia region, where we can see that the happiness level dramatically increased from 2013 and 2014, followed by a gradual rise up to 2016, then a sudden drop in 2017, and continued to climb up in the following years. The second graph, which is the figure 6.2, the status of happiness in the East Asia region, where we can see that the happiness level of the people rise up from 2012 to 2013, however, decline in the year 2014, and followed by a small increase in the year 2015 with no little changes in the next year, then significantly increased from 2016 to 2019. So the third graph, the figure 6.3, the status of happiness in the Asia Pacific region, which remain on top over the years with a score range of 7 points. However, there's a slight drop beginning in 2019. As mentioned earlier in the introduction or in the rationale, the South region showed a significant fluctuation trend in terms of happiness levels from 2018 to 2019, as you can see in the figure 6.4. The figure 6.5, the status of happiness in the Southeast region, where the fluctuation trend also is evident from 2016, 2017 to 2019. The figure 6.6, status of happiness in the Western region, almost have a relatively the same happiness level on average as the same as the East region, but a downward trend of happiness starting at the year 2017 to 2018 and slowly recovering during the year of 2019. So here the table 6.1, which is the descriptive analysis, where we can see the observation. It has a total of 328, all of which are from countries in the Asia Pacific region between 2012 and 2019. The mean or average is also presented in each variable. However, as we know, average has high data variation, and the average mean cannot provide an accurate result. The outliers, rather than the normal values, would dominate the mean value, and that's according to during 2018. The table also showed the standard deviation in which the happiness index, the inflation rate, the unemployment rate, the income and regional classification have a low standard deviation value, which means data are clustered around the mean. Also, the rest of the variables not mentioned have high standard deviation, which data are more spread out. So the last three columns are, the two columns are the minimum and the maximum, which is the smallest value in the data set is the minimum and the largest value in the data set is the maximum. Now, to find the macroeconomic factors affecting happiness, the researchers use regression analysis, and in this table shows the final model with the regression findings. The table also includes the variable coefficients as well as each variable's p-value. The final variables are the happiness index, the corruption perception index, the inflation rate, as well as unemployment rate, global freedom score, income classification, and regional classification. The PROV-F has a value of 0.00, which indicates that all levels of significance for the variables are jointly significant. So since the multicollinearity in the econometric model is less than 10, the variance inflation factor, or the VIF, which has a value of 3.01, is not a serious problem. For the coefficient of multiple determination, which is the R squared, has a value of 0.8375, implying that 83.75% of the total variance of the happiness index is explained by the independent variables. Now, the model reveals that the corruption perception index, unemployment rate, the global freedom score, all income classifications, and regional classifications such as Central, East, Pacific, and South significantly affect the happiness index at all levels, and a few variables, specifically the Southeast region at the 5% level significance.
A pleasant morning once again, everyone. Reflected in this table is the significant association of these determining factors at all levels of significance. In this figure, we can see that corruption perception index is statistically significant at all levels and is positively related to the happiness of a country. The model connotes that an increase of 1 point in the corruption perception index will cause the happiness to increase by 0.012 points, letting other things hold constant. This indicates that the less corrupt or cleaner administration note that CPI here is the perceived corruption that an individual perceive from their government, and a scale of 0 to 100 became the basis of the score, where a score of 100 means a clean government and 0 is a corrupt. This indicates that a less corrupt means a cleaner administration leads to a greater life satisfaction or happiness. The result given here conform to the related literature of Lang 2012, Wu and Zhu 2015, and Dejankov et al. 2015, or mentioned related literature that corruption can decrease the happiness, and it also goes to say that on a vice versa effect, the cleaner the government is from the corruption, the happier is the country. The inflation rate, on the other hand, leads to a decrease in happiness index by 0.11%, holding other factors constant, but this variable reveals to be insignificant at all levels. Next, we have the unemployment rate, which can cause a significant decrease on the happiness index by 6.27% for each percent increase in the unemployment rate, assuming that all other factors are constant. The negative relationship between unemployment and happiness are supported by the findings of the study of Dow 2017, Eberl et al. 2021, and Richer et al. 2020. Furthermore, the unemployment rate aligns to Layard's definition of the Big Seven influencing well-being coming under the category of work. And this also adapts the inner concentric ring that Kate Raworth in her theory referring the social foundation, specifically the income and work, as a contributor for a safe and just space for individuals, which was considered to be life's essential that no one should be left falling short of. Next, we have the Global Freedom Score. This holds to be a determining factor also of the happiness index, where it shows that there is a positive effect on the well-being, that as the country's global freedom score increases by 1 point, the happiness also will increase by 0.0037. This finding is backed up by the theory of Walsham-Thompson radical democracy theory, which adopts the concept of happiness in democracy to the principle of social interaction as well as a way of governing. Countries in the Asia-Pacific region here are categorized by income class, and the model shows that all income classification are inversely related to happiness and significant at all levels. And the regression results indicate that those countries belonging to low income, low middle income, and upper middle income classes have a lower happiness index compared to countries classified as a high income class, ceteris paribus. Those countries classified as low income will have a 150% lower happiness, and countries belonging to low middle income also has a lower happiness index by 117.33%, and similarly, upper middle income countries have a lower happiness index by 56.78% than those belonging to high income countries. This supports the finding of Richard S. Sterlins that states in the short run, a person's income level is directly related to the level of happiness. That is, relative income status really matters, showing that those with more income tend to be happier, and while those with less income tend to be less happier. And one of the categorical variable that we've incorporated in this study is the regional classification of Asia Pacific region. And in this manner, it goes to show that compared to Western region, which is the base variable, people in Pacific and Central Asia region are happier than those countries belonging to Western region. However, the happiness level of Western region also or happier than compared to those countries belonging to East region, South and Southeast Asia region. This is the summary of the result, and we can see here that the corruption, the result of each macroeconomic determinants affecting the happiness index. And in this slide, we can see the final model, and we've incorporated here the constant variable along with the slope coefficient of each macroeconomic determinants affecting happiness. For the conclusion, corruption, other macroeconomic determinants except inflation rate appears to be significant on happiness index. Thus, we reject the null hypothesis that there is no relationship between these macroeconomic determinants to the dependent variable happiness index.
The researchers' recommendation. There are several studies stating that happiness increase, productivity, and workers' effort, and that economists or economic heads should significantly consider happiness or the emotional condition of economic actors in general, supports the notion of necessity of happiness assessments. That's according to Oswald Proto and Segroy 2015. The researchers suggest that the government and other policy-making bodies broaden their basis on economic policies that and include the happiness and well-being of the people in planning for economic growth and sustainable development. To conform to the theory of Kate Raworth's donut economics, to change the goal from endless GDP growth as the basis of economic growth to thriving into the donut, social foundation, ecological ceiling. Just like other countries that have already recalibrated their focus and started leaning toward happiness and well-being in creating economic policies and regulation. For example, New Zealand recently launched its well-being budget in 2020 and has been always in the top of the happiness ranking. The United Arab Emirates, where they have the Ministry of Happiness, then has been the happiest Arab country for 6 consecutive years. And according to EDA 2020, in 2022 World Economic Forum, Japan already embracing the concept of well-being in economics. The researchers recommend, based on statistical evidence and the result of the study looking into the macroeconomic factors that affect happiness of the country, the Corruption Perception Index, the government should address corruption issues and should try their best, if not eradicate them, then mitigate them. Global Freedom Score, the free the people, the happy they are, thus policies should not hinder or affect people's freedom. For unemployment rate, the government should increase job opportunities. Income classification, that government and other economic policymakers should create policies to increase the country's income. And regional classification, there should be a need for interregional collaboration such as ASEAN in creating policies for happiness and well-being. To end, according to the former director of Sustainable Development Solutions Network, Jeffrey Sachs, the World Happiness Report has proven to be an indispensable tool for policymakers looking to better understand what makes people happy. Moreover, Sachs also stated that leaders need more inclusive metrics to effectively track and lead the progress of their nation. As the result, our research will actually assist government leaders and policymakers in realizing the concept of progressive nation for sustainable development. That's all, and thank you so much, everyone.
Thank you, authors. So we now have come to the last but a very important topic, networks of economic activities. So let's listen to James Matthew Miraflor, the co-author in the first study from the Department of Computer Science, UP, to present on learning probabilistic networks of economic activities from collocation. Please proceed. James, please proceed with the presentation.
Okay, sorry, I'm muted. Okay, sorry. Hello, can you hear me?
Yes, I can hear you well.
Okay, sorry for that. My task for today is to describe how local economies, or basically economies, can be represented using techniques from the probabilistic graphical methods, specifically Bayesian networks. And using these Bayesian networks representing these local economies, we can try to deduce the relationship of each economic activity types from each other, how each type induces one or the other, and hopefully we can use this since this is a probability distribution, we can use this to simulate actual economies from data and hopefully predict the evolution or trajectories of local economies. Okay, so the outline of my presentation, basically I'll be discussing the motivation, which is the use of Hirschman linkages and how the notion of Hirschman linkages have been treated in literature. And then I'll introduce my method, it's employing Bayesian networks and learning the structure of those Bayesian networks from data. We'll discuss the data that we have from the Census of Population and Housing Form 5, the barangay schedule, which features data on the presence or absence of specific economic activity types and other amenities at the barangay level for 41,000 barangays. And then we'll discuss our results. So basically, the prime motivation for this study is that economic planning entails selecting optimal investment strategies, and these investments must anticipate backward and forward linkages, as we have seen earlier from the previous presentation. IO tables allow for the calculation of multiplier effects, but this is at the aggregate level and using gross value added. But for the perspective of the firm, the question is, if I locate in this particular municipality or barangay, what types of economic activities do I induce? And hopefully, these economic activities I induced, it may make my environment more sound. So it's like you're trying to find the ecosystem wherein you will fit best. That's for the perspective of the firm. For the perspective of the local economic manager, the question is, what kinds of establishments do I prioritize to incentivize? Right, because I just have a constrained set of resources through which I can use to incentivize particular economic activities. So the best way to characterize this dynamics is via the economic linkage concept by Hirschman, the same Hirschman as earlier. Basically, the specific industry types are described according to if they're backward or upstream or forward or downstream, and their linkages to other types. And then these linkages inform the schedule and structure of industrial support on specific locations. So here's the stylized description of Hirschman's linkage effect. So you have Chi-I, the net output of the industry, and the Pij, the probability that industry J will be set up as a consequence of the presence of a firm or an activity of industry type I. So it's a conditional probability. So probability of Xj equals 1, given that Xi equals 1. So these conditional probability distributions derive from ratios of industry inputs and minimum firm sizes to generate inputs. Basically, this is dependent on the input-output data. But we are not looking at the Chi-I, the net output of the industry, which this is basically derived from the input-output table. We will be looking at at the Hirschman's linkage effects more precisely by focusing on the probability distribution, on the conditional probability distribution, PIJ. So basically, it's a ratio of marginals, the linkage probability as joint probability of industry J and I divided by the probability of industry I existing in that particular location. And then we can compute for the marginal distributions. And that's I mean that this is basically a basic algebraic manipulation. So the joint probability of Pij and Pi can be seen as marginal distribution from some other joint distribution that involves all other variables, px1, px2, px3, px1, 2, 3, etc. So to get pxi, you just sum it across all other i's to get the marginal distribution. But the problem here is that this method is of exponential time. It will take you an exponential time to compute for a particular marginal. So for instance, if you have 50 economic activity types, so you'll have and it takes 1 second. It takes 1 second to run a particular calculation as pxj equals 1, for instance. It will take you 2 to the 50 seconds, which is really more, I mean, longer than the time universe has existed. So it's really a huge deal to reduce this. So we exploit to solve this. We exploit the economic fact that the way establishments are distributed across phases in related to their interaction to one another. So if we have available location data on firms, infrastructure, urban amenities, etc., then we have information on the presence or absence of economic activities in geographic subspaces. So from this presence or absence data, we can generate information on Hirschman linkages, and that one we can use for local industrial planning. So which brings me to my methodology. So from the full joint distribution above, the px1, x2, x3, xn, we are going to reduce it to a particular representation. And we use that as representation, the Bayesian network. The Bayesian network is a staple in machine learning and in computer science, basically. And it defines a unique joint distribution over X, the set of X's, as follows. Probability of the joint probability of X1 to Xn is represented as factors, as a factor of parent-child distributions. So you have the probability of Xi given its parents, not all the variables, but just a limited set of parents. Taken, of course, from the superset X. So this will drastically shrink computation time, because instead of flipping the switch, so to speak, in all xn, we're just going to flip the switch of the parents. So and then the inference of marginals is basically defined already by belief propagation methods, which I won't be discussing. But this is almost polynomial time in some instances. So this is an example representation. You have x6 having as its parents x3, x4, and x5. So that's why you have here below, you have the probability of x6 given x3, x4, x2, and x5. And then you have, sorry, that you're not supposed to put in the x2 there, sorry. And then you have x3 given its parent x1, x4 given x2, and x5 given x2. And then finally, probability of x1 and x2 as its own parents. So the assumption here is that first, sorry, what happened? Okay, there is conditional independence. So given the parent, given its parents, the particular variable xi is already independent of the rest of the variables. So this implies that the interaction set that we have are exhaustive. is exhaustive. And then second assumption is that the underlying structure is represented by DAG, which is not a fatal assumption, especially for production, because production proceeds in steps anyway, right? So you have these initial inputs processed by this middle inputs, and then that middle one is processed by others until you get to the final demand. So it's not really a fatal assumption if we use the Bayesian networks for our particular case. Just some more nomenclature. We define the database Y. This is basically just a table of, you have rows as the observations, and then you have the columns as the value of the XIs, the presence or absence of particular economic activity types. So this is just a table basically. But from there, we can define precisely what structured learning means. So given a database Y and a scoring function, we will score the possible Bayesian networks. We will find the optimal Bayesian network, which maximizes the score over the space of possible Bayesian networks given the database Y. The problem here is that scoring all Bayesian networks is intractable. So this is the number of possible Bayesian structures given the set of nodes. This is still of exponential time solving this particular f of n. So we'll have to reduce it even further. But nonetheless, this is less than the exhaustive search. So right, so para you already have that gain. So we have another view. So given a database Y and a scoring function, we have the particular maximum likelihood approach, which we discussed earlier, but we also have the Bayesian approach, which calculates analytically, not exhaustively, analytically this particular Bayesian representation of the Bayesian network. So when you say Bayesian networks, it's not necessarily Bayesian. The learning that Bayesian networks is not necessarily Bayesian. It can be maximum likelihood. But there are Bayesian methods to learn Bayesian networks. So that's an important distinction. So with enough data, the Bayesian method approaches maximum likelihood, the information theoretic method. So just some more nomenclature before we proceed, just to be more precise. We denote R as the number of states, Q as the number of configurations of the parents, Nijk, the number of instances wherein that particular Xi takes a particular value and the parents takes a particular jth configuration. So this is just a set of possible configurations of child and parents. Right. So from that formula, we can calculate the maximum likelihood. So our scoring function is no longer an abstract function. We can precisely define it as follows. And then this is the maximum likelihood score. It's almost never zero, so makes sense to add parent-child relations to maximize the log likelihood, leading to a fully connected tree. And this optimization strategy is of O log n and over pairwise mi, which is O of n squared. This is how we learn the structure from data. So MSD is undirected. We need to add direction. So to introduce direction, we just use the result from Verma and Pearl that DAGs with the same V structures encode the same Bayesian networks. So I'll just breeze through this. The principled approach is that if we have already a minimum spanning tree, which is which represents the data, the Bayesian network which we learn from the data, then we can add arrows as follows. So we find the most central node in that learned network, and then we using between a centrality, you can use eigenvalue centrality, you can use all sorts of centrality functions, and then you do a breadth first search that from that node we put arrows away from that until you reach the leaf node. So that's the maximum likelihood approach for learning the structure. For for the Bayesian method of learning the structure, we use the Bayesian-Dirichlet equivalent with uniform prior distribution, developed by Heckerman, Geiger, and Chickering in 1995. Given a sample size, and you have this particular formula. So this is demonstrable. One can prove this, but this is already the best for this solves this particular integral. The integral above, the solution to that is the formula below. So maximizing BDEU is still NP hard. So even if it's no longer exponential time, it's still NP hard. So you have to explore a combinatorial search. So from the data, just to describe the data that we have the Philippine Census of Population and Housing, Form 5, barangay schedule. This contains 42,000 information for 42,000 barangays and 56 data points per barangays. But we will only use 40 binary variables for this exercise because this is computationally expensive. Yeah. So this is the data points that we are using. So the features, town hall, if it is a church, if it is a cemetery, public plaza, marketplace. You have education data points. If the barangay has an elementary school, high school, library, healthcare, hospital, barangay has station. If the barangay has a landline calling station, if it has fire protection services, public street sweeper, seaport, and other modes of transportation if it is present in that particular barangay, and establishments. So by industry and by employment size. So you have commercial 10 employees, commercial 10 to 99 employees, commercial more than 100 employees, manufacturing same, manufacturing 10 employees, manufacturing 10 to 99, etc. So we have commercial, recreational, manufacturing, hotel, banking, etc. So this is a very huge data set. So if we just characterize the data properties, we'll notice that they are sort of governed by a power law. So this is just a good observation, but there is some sort of regularity wherein the log size and log rank. I mean the number of particular municipalities having this particular number of establishments is very regular across time and across activity types. Yeah. So this is how we can map. We are mapping the distribution just to give a taste on how it is distributed across space. So this is for Naga, the distribution in commercial. How the auto repair shops are distributed. As you can see, it really clusters along roads. Of course, that's very logical. But so is manufacturing. All right. So there. So you have this particular information. So from there, you can already sort of have an intuition that commercial areas cluster where manufacturing areas are. So this is our result. So we use the Python package probabilistic PGMPY, and then we use sklearn to calculate the mutual information matrix, and other graph algorithms are already in network X. And we represent the Bayesian network using XML BIF, which can be read by other software, particularly SAM-IAM and others. Bayes server. You have other software, Open Markov, that can read this. So you have this result from the maximum likelihood information theoretic approach. You can generate this particular network of economic activity types, wherein commercial determines commercial 10 to 99 determines the presence of recreational 10 to 99, and then recreational 10 to 99 generates or determines the presence of bigger recreational areas. You have landline telephone systems determining other activity types, etc. So there's a sort of a hierarchy is formed by looking at the network itself. So not only that, but this particular network is a probability distribution itself. So you have this is the prior probability distribution for each data point. So the probability that there's a public library is just 6.42%, etc. This the probability that the personal services of less than 10 is 31.35% for any given barangay. But you can flip the switch. So given that we know that there is already a personal services establishment of less than 10 employees in that area, we can see how it changed and how the information propagates across the network. So first, the probability of recreational areas increase by almost double, right here from recreational less than 10, and you have and you can also flip the probability distribution for other areas. So if we know that there is a commercial area, the probability the probability that other activities are also there is also raised accordingly. So you have an idea on the hierarchy of economic activities, what you can induce. So there, this is just I'll just breeze through this. This is the using the Bayesian structure. We used evolutionary algorithms because this is really very difficult to deduce, to compute. For using Bayesian methods, we arrive at this particular network. We only use 8 variables because that's the only set that my PC can take, my laptop can take, and we have this particular network. So, but just the same, it's also a probability distribution which you can flip, and you can calculate how the probability distribution of other variables change and propagates across the network. So just to demonstrate, here's a more complex network. As you, when you flip one particular node, it propagates across the network, and this network is a DAG, which means that there is a particular central node there somewhere, and you can even do both at the same time. Okay. And note that since this is a probability distribution, this network is actually a probability distribution, we can use it to simulate actual economies. So this is just a blank map, and then using the network that we learned, from there we can generate simulated economies. So it's like since we know the underlying function which generates the economy, we can predict how economies evolve across time and space. I'd like to end there. Thank you for listening.
Okay, thank you for the presentation. So we only have a few minutes left. Alex Escucha was raising his hand earlier. Alex, do you want to raise your question? Alex, by the way, was former PES president. Alex?
Thank you, Doris. I'm continuing my tradition from yesterday of asking a question. My question is for the happiness index paper. This is a session which I'm sure Dr. Mahar Mangahas would have loved to attend, because he has been a strong advocate of actually measuring happiness. My first question is, I didn't catch exactly how the dependent variable is exactly measured. Is it measured by a survey a la SWS?
Good morning, sir. Yes, sir, it is measured by a subjective survey from Gallup World, sir. And the survey is based on a country ladder where the respondents can answer from 0 to 10. Sir,
Of how happy they are.
Yes, po, sir.
And what is the frequency of that measurement?
Ano, sir, they use as a country ladder, sir, where 0 to 4, I mean, respondents who answered 0 to 4, they are considered as Wait, sir. Struggling.
Well,
Yeah, there's-
I mean, how often? Is that an annual,
yeah, sorry.
semi-annual?
I apologize for sir. Yes, sir. It's an annual survey, but conducted by the Gallup World, sir.
Okay. You know, I find I'm attending simultaneously 3 sessions, but I really listen to your session intently because I intend to raise this with Secretary Balisacan because the advocacy, I share the advocacy of Dr. Mangahas that because income is a major, has the biggest coefficient, no? Income. The question is, yung ating FIES, meaning the Family Income and Expenditure Survey, used to be measured every 4 years. Now, Secretary Balisacan says they will start measuring it every 2 years. Plus, there is a disaggregation not only among the regions, but across provinces. We don't have that disaggregation kasi. So your study is across countries. Okay? And then, because if we really want to see what is the real measure of the effectiveness of our 5-year development plans, the methodology used in your paper should be an important part of the metrics or KPIs that should be measured there. But again, it means that while we measure inflation monthly, and for example, last week, 84% of the increase in the inflation rate was accounted for by food, which in turn hits the lowest income classes most strongly. So talagang yung impact on welfare and sense of poverty is very very strong. So I commend you and your team for this very good study. My third point is that I'm a fellow of the Foundation for Economic Freedom, where Dr. Olfa Bella, Secretary RC, Mahar Mangahas are also members. And 3 weeks ago, there was this Economic Freedom Index, which also measures indirectly corruption, but economic freedom. And Philippines is rated very low on rule of law, the security of property rights, which is directly correlated to 1 or 2 of your indicators. So I would like to touch base with you because I think you can make a career out of this. And it sorts of, I would like to have a copy of your paper so we can share it with our fellows in the Foundation for Economic Freedom. And then I would like to share with you also the full report of that the Economic Freedom Index, which is done annually, again on a global scale. We're doing very well on macroeconomic management, on monetary policy, but we're very poor on rule of law and protection of property rights. And the bureaucracy, the red tape, again, which hits the lowest income people the worst. So, Ms. Doris, pwede ba yun? Can sort of touch us together because I think this is a very, very promising. It's a pleasant surprise for me for this young group of economists from MSU IIT. Congratulations.
Thank you so much, sir.
Thank you, Alex. That's possible, and I hope that you and the team of Mr. Sumagang can communicate from here onwards. But we only have 1 minute remaining, so and there are no other questions. So let me make a few comments. Doon sa presentation of the MSU, inflation as insignificant no? That seems counterintuitive kasi fast increases in prices make us unhappy, di ba? So you probably need an explanation for this.
Yes, yes.
I'm thinking baka may possibility of overfitting na kasi overfitting happens when you throw in so many explanatory variables, thereby rendering counterintuitive results. And nakita ko na high yung R squared ninyo, no? We need high R squared kung we are trying to use the equation for its predictive power. Pero what you're trying to do here naman is kung yung explanatory power. So the high R squared is not that important, kundi yung significance of the coefficient. So explore yung possibility of overfitting, no? Doon sa
It's possible kasi that the time series they use did not yet include the bump in the inflation rate of the previous months. Kasi more risk. Since 2008 kasi, di ba, low interest, low inflation period. So that's
Okay.
possible that happened. One last item lang, there is the reference point that people have is the only government country that measures gross national happiness is Bhutan. So I was wondering whether there's any way to link how they measure that in Bhutan and sort of incorporate those elements into your study as you enhance it further. Thank you.
Thank you, Alex. And then before we leave the room, a few comments din do sa other presentations. Do sa presentation ni Mr. Castillo, critical assumption yung continuous function, no? For you to be able to use yung interpolating polynomial and then generate the entries dun sa interpolated submatrix. But this seems na it's not approximating reality because of jumps in input utilization and output production in sectors, say because of firm entry or exit or shocks in particular sector. So it's something that you might want to ponder more. Itong kaya Mr. Miraflor's presentation on collocation of economic activities. So yung kinonsider mo in the data set, no, mostly services establishments and a few manufacturing establishments. So would it be important to see also yung collocation networks with primary production areas like farms and fish landings, as well as sources of raw materials? Perhaps yung effect of distance or connectivity factors in collocation decisions and probabilistic approach then. So it would be good to explore how that can be done using your methodology. And now 10:27, I have to end this session. You don't need to answer. Those are just points for consideration as you polish your studies. Okay, thank you. Thank you everyone for participating in this session. Okay. Bye.
Thank you, ma'am. Thank you, ma'am.
Thank you so much, ma'am.